Let's look at some examples where we will be solving logarithmic equations. So let's solve the equation log base x of 32 equals 5. Sometimes we can simply rewrite this as an exponential equation to allow us to solve it. So here, if we convert this to an exponential equation, our base is x. So we have x, our exponent here would be 5, equals 32. So now we can mentally solve this if we think about it. We're looking for what x value raised to the 5th power gives us 32. And the answer is 2. 2 to the 5th power gives us 32. So that's our answer for part A. For part B, we have log base 6 of x equal to a negative 1. So let's do the same thing. Let's convert this to the exponential equation. So here our base is 6. Our exponent is a negative 1 equal to x. Well, I can write 6 to the negative 1 as 1/6. And that is what x is equal to. X equals 1/6. Now let's look at some examples of solving exponential equations. In this first one, we have e to the t equals 10. So we're trying to solve for t. That's our variable. And our variable is stuck up in the exponent. So the question is, how do we isolate it and solve for it? So what we can do here is take the natural log of both sides of the equation. So the natural log of e to the t equal to natural log of 10. So this is referred to as taking the natural log of both sides. And the reason I chose to take the natural log of both sides is because our base in this case is e. So here's what will happen. We can apply one of the properties of logarithms that allows us to bring the exponent out in front. So then we have t times natural log of e equals natural log of 10. Now natural log of e, well, that's going to go away because the natural log of e is 1. So we then have t equals natural log of 10. So the exact answer for t would be natural log of 10. If we wanted a decimal approximation to this, we can plug natural log of 10 in our calculator by using the ln button on your calculator. And what you should get is 2.30 if we round to 2 decimal places. For part B, we have e to the 2t equals 1,000. So we're going to do the same thing. To get that variable isolated, we're going to take the natural log of both sides of the equation. So we have natural log of e to the 2t equals natural log of 1,000. And once again, I chose to apply the natural log to both sides since my base is e, and natural log of e ends up being 1. The property of exponents, the property of logarithms that allow us to bring the 2t out in front, we'll do that next. So we have 2t times natural log of e equals natural log of 1,000. Once again, the natural log of e goes away, and that's equal to 1. So we have 2t equals natural log of 1,000. Divide both sides by 2, so we get that t is equal to natural log of 1,000 divided by 2. And that would be the exact answer for t. If we wanted a decimal approximation, we can plug natural log of 1,000 in our calculator by again hitting that ln button on the calculator. And then natural log of 1,000 divided by 2, rounded to 2 decimal places, gives us 3.45. Alright, let's do one more example solving exponential equations. We have e to the negative 0.02t equal to 0.06. So once again, we want to solve for t. So to do so, we're going to take the natural log of both sides. So we have natural log of e to the negative 0.02t equal to natural log of 0.06. Keep in mind, whatever you do to one side of the equation, you also have to do to the other. So we're taking the natural log of both sides. Now the property of logarithms tells us that we can bring the exponent out in front. So we have a negative 0.02t times natural log of e equals natural log of 0.06. Once again, the natural log of e goes away since that's 1. And then we're going to divide both sides by a negative 0.02. So we have t equal to natural log of 0.06 divided by a negative 0.02. That is the exact answer for t. If we want a decimal approximation, plug that in the calculator. We have natural log of 0.06 divided by a negative 0.02, and we get 140.67 rounded to 2 decimal places.